right?
Yeah.
Good. All right. So what I'm going to do is just kind of talk you through this, and then I'm not going to take the time to actually write every single step out unless you feel like you need to see it, okay? Because it looks like you have a lot of questions here, and we only have a little bit of time. All right. So this says, given that PR, so I like to write these things in. PR, what you've done here, is congruent to ST, and that NP right here is congruent to VT. So we'll put 2 tick marks there. And P is congruent to T. Angle P is congruent to angle T. It's saying to prove that WRS is isosceles. So they want us to prove that WRS, which I'll put in white, WRS is isosceles. So we would need to prove basically that this is equal to this. So let's come up with the plan, okay? Well, this being equal, and if I add the RS to this one right here, if I add RS to ST, and if I add RS to PR, then that would give, by the addition property, that PS is equal to TR. Do you understand that?
Yes.
And then I can say that this triangle right here, RTV, is congruent to triangle SPN.
By a side angle side.
Very good. By side angle side. Okay. Then once I have that, I can say that this angle is congruent to this angle by what?
CPCTC.
That's right, by CPCTC. Got it? So that's the plan of attack.
Yeah.
Okay. Does that make sense?
Yes.
All right. So I'm not actually going to write that out right now because we'll come back if we want to do that later, if that sounds good. All right. Let's just go through all these and talk through the reasoning. Make sense?
Yeah.
And you stop me if you're confused by anything. So FG is congruent to JH, and FGH, this whole angle right here, is congruent to JHG, this whole angle right here. Okay, so you kind of have to be able to visualize these triangles, right? Can you see that what I have here? Here's one angle here, triangle here.
Yeah.
See that? I'm gonna use a different pen here to color it. So that triangle, can you see it?
Yes.
That's what I'm looking at, and I'm looking at this triangle also. Do you see those two?
Yeah.
I want to show that those two are equal to each other, I think. Well, let me make sure. FKJ. Yeah, they want me to show that this is isosceles. So I want these angles. Let's see, do we know what kind of triangle these are?
Is this a scaling triangle?
Well, did they tell us that these were parallel or no? They didn't say this is a parallelogram. No. Okay, so we can't maybe assume that. So let me just go with my gut. My gut says that I need to use this side right here down at the bottom. That is equal to itself. What property or what reason?
Reflexive.
Very good. Perfect. So if I get this one, then I can have that this blue triangle is congruent to this yellow triangle by what?
Side angle side.
Perfect. By side angle side. And then I can get that this angle is congruent to this angle by CPCTC, but that actually doesn't prove anything to me yet. So let's see. What I would like to get is this triangle here congruent to this triangle here. You know what I'm saying? And then I could say that those two sides are equal by CPCTC, but I'm
okay.
Yeah, but I'm trying to think of how I can do that. I don't know that I can do that because this side is not part of that blue triangle. So I would have to, I don't really have that these two are equal to each other, or is this all that you were given? You weren't given anything else?
No, this is it.
F, G, H, and J, H, G. Okay, I did that right. And F, G, and J, H. So obviously these two triangles are congruent to each other, right? By what we just talked about.
Yeah, could we use vertical angle theorem?
Oh my gosh.
Because we could do FKG is congruent to JKH, and then
we can, but we need another side. We need another side or another angle. But I do like what you're saying. That's good thinking. And that might be something we can do in a second. But first, let's think about it like this. If I take this, I want this triangle is equal to this triangle, right? Yeah. So what I can do is I can say that this angle right here, that angle is congruent to that angle by what?
Ah, my God. Wait, what is this called?
But this is a contour or a detour proof, maybe.
Oh, wait, I don't think we learned that. I think there was another name that I learned. Is it?
Well, this is equal to this by CPCTC, right?
Yeah.
Okay, so, but that's not the angle I want. This is the angle I want right here. So then I can say that that is equal to that by what property?
Is there a theorem for adding angles together?
Yeah, it's the subtraction property.
Oh, yeah.
Because we're subtracting, right? We're subtracting this red angle we already have, that was given. This blue angle was by CPCTC.
Yeah.
Right? And so that's the subtraction property. And so now what do we have for this smaller triangle right here? We have a side and we have an angle. And like you said, we have another angle.
Yeah.
And that's by what? You just said it.
That would be by vertical angle theorem.
Very good. That's vertical angles. Got it?
Yeah.
So now I have that these two triangles, I'm going to change the color on my pen here. This white triangle is congruent to this red triangle.
Yeah.
By what? Do you see how I have angle, angle, side?
Oh yeah, angle, angle, side.
By angle, angle, side there. Okay. And then we can say that this, or that these two sides, what's the isosceles? Is it sides are equal? What's the theorem, or the definition that you have? The sides or the angles, or can you use either?
Either.
Okay. If you can use either, then just pick one of them. You can say FK is congruent to KJ by CPCTC, right?
Yeah.
That makes sense how we did that?
Yes.
All right. Moving on. You got some, that was a tricky one. There might have been a quicker way to do that one. I don't know, but I didn't see it on that. All right. So this says in the graph, if a perpendicular is drawn from T to PA, from T to PA, a perpendicular is drawn. So that means they drop it straight down. Okay. So that's your perpendicular. Let me change the color on that.
What will be the coordinates?
If a perpendicular is drawn, what will be the coordinates of the point where the perpendicular intersects PA? So they're asking for what this point is right here. Okay, so we have to do a little bit of, and they say that this is a, let's see, what do they say? Well, we can just figure this out without knowing the details. this point right here is 2, 1. That means I go over 2
Mm-hmm.
and I go up 1, right?
Yeah.
And this point T is 3 point, I'm sorry, what does it say right there? 6.82?
Yeah. Wait, so then wouldn't it just be 3.41?
No, that's the Y coordinate for it. The X coordinate is 6.8.
Oh wait, my bad. Wouldn't it be 6.821?
6.82 comma 1. That's right.
Okay, that one was
6.82 comma 1. Yep. So that's just about reading a graph.
mm-hmm.
Yep. That was it.
All right.
Moving on. Given that WX is congruent to WZ and XY is congruent to YZ, and they're basically saying that that's a kite. So you know one of the properties of kites, WPZ. Don't you know one of the properties that they want you to prove it? They don't like to use the fact that you know that's true. Oh, that's okay. We don't need to use that. We don't. I thought that one of the properties of a kite was that the diagonals are perpendicular to each other. That's a property of a kite, but they're basically wanting us to prove that property.
Okay.
They're wanting us to prove that WPZ is a right triangle. So, so what I have is, let's see, how can I prove this? So I'm just thinking things out. First of all, if I draw this side in right here, WY, it's equal to itself. And that will give me what?
It's a reflexive, it's equal by reflexive property.
Yeah, they're equal to each other, right?
Yeah.
So that's the first thing I would do is prove that this triangle is congruent to this triangle by side.
Uh-huh.
And then we would use that to find this angle. I'm going to do this kind of quick. You can go back and watch the video. So this and this are equal to each other by CP/CTC.
Uh-huh.
Right? And let's see. And okay. And then I can say that this triangle is congruent to this triangle by what?
By angle.
Well, I'm sorry. First, I'd have to say WP is congruent to itself.
Yeah, by reflexive property.
Reflexive.
And then it's congruent by side angle side.
Perfect. Good. So now I have this triangle and this triangle. Got it? Yeah. And now, since those are equal, I'm going to say that this angle is equal to this angle. Do you got it?
Yeah.
But if those angles are equal to each other and they also are supplementary,
that would have to mean they're right angles.
Yeah, you have a property that says that, right?
Yeah.
Yeah. So that would mean that they're right angles, and that would prove what they want you to prove.
Okay, thank you.
Make sense?
Yeah.
Okay. Next, you didn't think we'd get through this many, did you?
No.
Yeah, we're fine. All right. Are we going too fast, or is this good?
This is good.
All right. So given AG is perpendicular to bisector to BC, so AG is a perpendicular bisector to BC. So that means that these two are, we can prove that those two are equal by definition of perpendicular bisector, and we can state that all of these are right angles by definition of perpendicular bisector. Yes. Right? Yes. And AG is a perpendicular bisector to DE also. So for this, by the same token, we say that those two and these two by definition, right? Yeah. And they want us to conclude that BD and CE are congruent to each other. BD and CE. So this is in white is what they want us to conclude, that those are congruent to each other.
Wait, could BC be a mid segment?
What's the definition of a mid segment?
It says a mid segment of a triangle is a segment connecting the midpoints of two sides. So it says like, okay, so
Yeah, I think that's slightly different. That's saying you've got a triangle like this.
Mm-hmm.
Let's say I have a triangle and I take the midpoint. So that's a midpoint, which means those are equal to each other. And that's a midpoint, which means those are equal to each other. And I connect them like that. That's called the mid segment.
Oh, okay.
But that's not what I have in this picture.
Okay.
Right?
Yeah.
But I like what you were thinking. That was a good thought. What's another thing we can do to prove that those two white X's are congruent to each other? What's a plan of attack we could use?
So if we could prove that BA is congruent to CA, or we could just prove that EA is congruent to DA, then
and that AB is congruent to AC.
Yeah. If we could prove both of those, then we could eventually prove that DB is congruent.
That's very good. Exactly. So we're going to use the subtraction property at the very end, right?
Yeah.
We're going to basically have that, like you just said, like AE is congruent to AD, and AC is congruent to AB.
Yeah.
Then we're going to say then DB is congruent to EC by the subtraction property. Right? So if we can prove this, then we can say this by the subtraction property. So you're exactly right. So how are we going to prove that this is congruent to this?
We could try and prove that if we could prove the triangle is congruent first, then we could automatically prove that they're congruent.
Perfect. CPCTC. So how can I prove that this triangle is congruent to this triangle?
So we already have one side. So we could do GA is congruent to itself. So that would be reflexive property.
Perfect. And we also have an angle.
Yeah. So then that would become side angle side.
Perfect. So that's the one. And how about this one here?
And then we already have an angle and a side. So we could just do reflexive property again. Yeah.
Perfect. That's it. That's all you got to do. So you're proving this is congruent to this, which means this by CPCTC. And then we're proving this is congruent to this, which means this by CPCTC, and then that by subtraction. Okay. Good?
Yeah.
All right, good job. You got this. You seem to begin this down pretty well. Now I have to see you writing it up. It's one thing to understand it, but it seems like you understand where to go. Right?
Yeah, which is good. I know what to do, but I don't know how to place it like in steps on the paper.
Okay. So that's something that we can work on Wednesday in person.
Okay.
Maybe you can take these or even other ones and just even redo these same ones and practice writing them out on paper in the right order.
Okay.
All right. 17, given that F is the midpoint of BC, so F is the midpoint of BC. So that means
we can say
F is the midpoint of BC. So that those are equal, right? By definition.
Midpoint, yeah.
DB, so let's write DB and EC. That's what's given. DB and DB and DF, that's given.
Yep.
EC and EC and EF, that's given. Well, now we have right away, what do we have? That triangle?
It's congruent to that triangle, but wait. No, we can't say they're equal yet, right?
We can, because of hypotenuse leg.
Oh, oh yeah, okay.
Because it's a right triangle, we can. If this wasn't anything but a right angle, we couldn't say that for a fact. But because it's a right angle, we can say that they're congruent by HL.
Yeah, got it.
Okay. So these are congruent. And let's see, does that help us? AF is perpendicular to BC. AF perpendicular to BC. So we need to prove that this is a right angle here.
Okay, so we actually already know that D is a right angle, so that automatically means, wait, hold on. We have to prove that AF is perpendicular to BC.
Yeah, we have to prove that this and this are perpendicular to each other.
Okay, so how are we supposed to do that?
I know, that's what I'm trying to think. This picture isn't drawn very well, so it's kind of hard for me to think it through, but that's okay. It's not a big deal. We know, so we can say this angle right here is congruent to this angle here, right, by CPCTC.
Uh-huh. And then if we prove the triangle congruent, we can prove those two congruent.
If we can prove that these two triangles are congruent, then we're good. But I don't know if I'm trying to see how we can do that.
We could do reflexive property first. Like
for this one, right? But we don't have, oh wait, we do have this side, but we don't have this angle. We do have, oh, there we go. Boom.
Oh yeah.
We know this is a right angle and that's a right angle, right?
Yeah.
And now we have this side and this side by CPCTC, and we have this side, like you said, by itself. So that's another hypotenuse leg
theorem. Yeah.
Hypotenuse leg theorem, and that gives us that this angle is equal to this angle.
Yep.
Which means this whole angle is equal to this whole angle, but they're also supplementary. So you have that property that says that they're right angles. Got it?
Yes.
That was a lot.
Yeah.
That was a lot of talking, but again, go back through the video and watch it, and hopefully it'll help. Okay, let's fly through this. Given S circles P and Q. Is that what that means, circles?
Yeah.
P and Q. And that PQ is a perpendicular bisector of RS. So PQ is a perpendicular bisector. So this is a right angle.
Yeah.
And it's a bisector. So that's equal to that. Got it?
Yep.
So, they want us to prove that. My bad. They want us to prove that. So all they're giving is that P and Q are circles. Okay. So there's a property. There's a property that says when you draw these radii in and you draw these radii in.
It would be radii of the same circle are congruent.
Right. There's that. So, this is congruent to this and this is congruent to this.
Yes.
There's a property, and I don't know if they're trying to have you disprove that property, but there's a property that literally says this. It's like the I can't remember how it's stated exactly, but they might be asking you to prove that, but that's basically what the theorem says. The theorem basically says this right here. It's in your book. I don't remember which chapter it's in or unit, but anyway, let's just prove it. So what I'm going to do is draw in this side right here, which is by reflexive, right? Yeah. So now I have I have those two triangles are congruent to each other by side, side, side. You got it? Side, side, side.
Do we have to say RS is congruent by reflexive property to itself? Or is that do we not need to do that?
No, we don't need that.
Okay.
We don't need that because what we don't have those triangles. The triangles that we have are these bigger ones. It doesn't include R and S.
All right.
Okay. But then we are going to, I think this is similar to one we did previously. So then we're going to say that this angle is equal to this angle. So then we're going to like draw in this line here.
Mhm.
Now we draw RS in. And now we think of these smaller triangles, this triangle here and this triangle here.
Mhm.
So this white one, I was basically saying that the bigger triangles, PRQ is congruent to triangle PSQ. That was the side. But then you're going to prove that we're going to have to name that point right there. Let's call it M for midpoint. Okay. So that point right there is point M.
Mhm.
So now we say that triangle PRM is congruent to triangle PSM.
Mhm.
And the reason for that one, if you look at it here, is you have to prove this side first and this angle first. So now we have side, angle, side. So that one will be side, angle, side. Got it? And then we say by CPCTC, we say that our angle RMP is congruent to angle SMP, and also they are supplementary,
So that would automatically make them right angles.
which implies that they're right angles. And if they're right angles, then they're perpendicular. And well, not bisector necessarily, but and this side RM is congruent to MS.
So then it would make perpendicular bisector.
There you go. You got it. Man, you're getting this well. You once I explain it, you jump all over it. So that's good. We just have to get you to learn how to see it, right? How to see it on your own, and then how to write it in the right way. So we'll work on that on Wednesday. Sound good? Sound good?
Oh yeah, now it's good. Okay.
All right.